Hello everyone, welcome back to the channel. Today we are diving into two super important concepts of linear algebra, which are linear combinations and spanning set. So let's just first start with the linear combinations. So for example, I am taking two vectors from R2 and naming those vectors as alpha and beta. Then randomly I am taking two scalars. Suppose here I am taking 1 and -1. Then I am multiplying the first scalar with the first vector and second scalar with the second vector. So 1 into alpha plus -1 into beta. So calculate the resulting vector will be 0 and -1. Then I am changing these two scalars to 1 and 0, for example. Then again doing the same thing, 1 into alpha plus 0 into beta, which is basically alpha itself. We have only taken the numbers 0, 1 and -1. So let's just take some numbers. For example, I am taking 2 and 5. And again repeating the same thing. 2 into the first vector plus 5 into the second vector. So the resulting vector will be 7, 5. So what we have done, we have started with two vectors alpha and beta from two-dimensional space. I have chosen randomly some scalars, 1 -1. For that I have received a vector 0 and -1. Then again I have chosen a new set of scalar 1 and 0. Then we get alpha itself. Then 2 and 5, we get 7 and 5. So if we just change these scalars to some more numbers like 3, 4, 5, 6 and so on. So how many vectors in this way we can get? The answer will be we can get infinite number of vectors by changing the scalars. Now let's just take all these vectors in a set. So there I am taking all these combinations like 0 and -1, then alpha itself, 7, 5 and so on. Here 0 and -1 I have received by taking some combinations of alpha and beta. तो अगर अल्फा और बीटा नहीं होता तो मुझे 0 एंड -1 नहीं मिलता. सिमिलरली यहाँ पे मुझे अल्फा खुद मिला है, मुझे अल्फा एंड बीटा का ही एक कॉम्बिनेशन से. देन 7 एंड 5 मुझे मिला अल्फा एंड बीटा का एक कॉम्बिनेशन से. सो these vectors 0 and -1 is said to be the linear combination of alpha and beta. अल्फा एंड बीटा का कुछ कॉम्बिनेशन करके ही मुझे ये वाला वेक्टर मिला है. Alpha also itself is called a linear combination of alpha and beta. Then 7, 5 vector, this vector is also called as the linear combination of alpha and beta. तो ये वाला जो सेट हम लोगों ने डिफाइन किया, ये क्या है? ये है हर एक जो लीनियर कॉम्बिनेशंस हमने बनाया है यहाँ पे लेफ्ट हैंड साइड में, तो उसको राइट हैंड साइड में एक सेट बनाया है. सो दिस सेट इज कॉल्ड द लीनियर स्पैन of alpha and beta, and this we denote as L of alpha comma beta. Since alpha and beta का combination से मुझे ये set मिला है, इसीलिए second bracket alpha beta and L denotes for linear span. Now if we just name this alpha and beta set as S, so this S set is called as the generating set or the spanning set. Now why S is called as the generating set or the spanning set? Because अल्फा एंड बीटा का कॉम्बिनेशन से ही मुझे ये हर एक वेक्टर मिला है. अल्फा एंड बीटा generates this set. So every vector, each and every vector is a linear combinations of alpha and beta. That is why alpha and beta इसको generate कर रहा है. And spanning set means a set alpha beta which increases in numbers and making a new set which is the L of alpha and beta. That is why this S set is called as the spanning set. Now learn the mathematical definition. So a vector beta is said to be a linear combination of the vectors alpha 1, alpha 2, alpha n if we can get some scalars c1, c2, cn such that पहले स्केलर को पहले वेक्टर के साथ मल्टीप्लाई किया, दूसरे स्केलर को दूसरे वेक्टर के साथ मल्टीप्लाई किया, nth वेक्टर को nth स्केलर के साथ मल्टीप्लाई किया एंड देन सबको ऐड किया एंड दैट बिकम्स बीटा. Then beta is called the linear combination of alpha 1, alpha 2 and alpha n. अगर ऐसा कुछ स्केलर ना मिले, so if we cannot get any c1, c2, cn such that we can write down beta as c1 alpha 1 plus c2 alpha 2 plus cn alpha n, then beta is not a linear combination of these vectors alpha 1, alpha 2, alpha n. Now in previous example, we have considered two vectors from the two-dimensional space. Here we have considered two vectors, but we can take 3 vectors, 4 vectors, 5 vectors, any number of vectors. And the vectors can be from R3, R4, R5 and so on. Now let's solve some problems. So some three-dimensional vectors have been given alpha, beta, gamma and delta. So the first question is we need to check alpha is a linear combination of beta and gamma. So alpha will be a linear combination of beta and gamma if we can get some scalar c1 and c2 such that c1 को पहले वेक्टर के साथ मल्टीप्लाई किया, c2 को दूसरे वेक्टर के साथ मल्टीप्लाई किया, दोनों को ऐड किया and ये जो मिला, if that becomes alpha, then we can say that alpha is a linear combination of beta and gamma. So for that basically we need to find out the values of c1 and c2. So let's just put all the values and check whether we can get any c1 c2 or not. तो अल्फा मुझे मिला 4, 3, 5. Then c1 beta plus c2 gamma. So we can find a system of linear equations in C1 and C2 which we easily can solve. So solving this set, we get the value of C2 as 2, C1 as 1. Now the value of C1 and C2 will put in the third equation and check whether these values are satisfying the third equations or not. 3 into 1 plus 2 which is 5. So the values of C1 and C2 is satisfying the third equation. So we can say that for the scalar 1 and 2, alpha will be a linear combination of beta and gamma. I will recommend in exam you cross check and verify whether your answer is correct or not by putting the value of C1 and C2 here and you calculate these things and you will get the alpha itself. So the second question is also same. So I am giving this as homework to you and I am directly jumping into the concept of linear span of a set. So we have a non-empty subset S. So the set of all finite linear combinations of the elements of S is called as the linear span of S, and which is denoted by L of S. Okay, so let us solve a problem. So alpha and beta are given. We need to find out the L of alpha beta. So L of alpha beta will be the set of all the linear combinations of alpha and beta. तो अल्फा बीटा का लीनियर कॉम्बिनेशन कैसा होगा? C1 इंटू अल्फा प्लस C2 इंटू बीटा, जहाँ C1 and C2 will be some real numbers. So you change this scalar and you will get one linear combination. Again you change this scalar, you will get one more linear combination. So in this way you can get all the linear combinations of alpha and beta. So that set is called as the linear span of alpha beta. So L of alpha beta will be this one. Now the second question says that examine if gamma and delta are in L of alpha beta or not. So gamma will be in this set if gamma is a linear combination of alpha and beta. So that we need to find out whether gamma is a linear combination of alpha beta or not. So we'll check whether we can write gamma is equal to some d1 into alpha plus some d2 into beta. तो हमें d1 and d2 का वैल्यू ढूंढना है. Now for some cases, if you can directly see and calculate what will be the d1 and d2 value, then directly you can go for that. But for some cases, it's better that you follow the process and find out the value of d1 and d2. From here we can get three equations which are d1 plus 2 d2 equal to -1, 3 d1 plus d2 is equal to 3, and -2 d2 equal to 2. Putting the value of d2 in the second equation, we can get d1 is equal to 4 by 3. But the value of d1 and d2, if we put in the first equation, so it will be 4 by 3 plus 2 into -1. 4 by 3 minus 2, which is not equal to -1. That means d1 and d2 value is not satisfying the first equation. So which means there exists no d1 and d2 such that we can write down gamma as d1 into alpha plus d2 into बीटा. तो ऐसा कोई d1 d2 नहीं है जिसके लिए गामा अल्फा एंड बीटा का लीनियर कॉम्बिनेशन होगा. दैट मीन्स गामा अल्फा बीटा का लीनियर कॉम्बिनेशन नहीं है. सो दैट मीन्स वी कैन राइट डाउन गामा does not belong to L of alpha and beta. This will be the answer. Now the second question, whether delta belongs to L of alpha beta or not, the process will be same. We need to find out some d1 d2, for which we can write down delta is equal to d1 into alpha plus d2 into beta, and we need to find out again what is the value of d1 and d2. So let's solve some more problems. So express the polynomial this one in PT. PT is the set of all polynomials as a linear combination of the polynomial P1, P2 and P3. Then we can write down nu as some C1 into P1 plus some C2 into P2 plus some C3 into P3. नाउ हमें C1 C2 C3 का वैल्यू ढूंढना है। सो न्यू का वैल्यू पुट करते हैं। Now comparing both the sides of this equation and this equation, we can get, here we need to solve this system of linear equations. Now if by substituting the values we can solve this linear equation, then it's okay. Otherwise we need to go for the procedure for solving the non-homogeneous linear equations. So these are the values of C1, C2 and C3 for which the polynomial nu is a linear combination of the polynomial P1, P2 and P3. Next we have been given a matrix M and we have to check whether M is a linear combination of the matrices A, B and C or not. Again the same process. If we can write down M as some C1 into A plus some C2 into B plus some C3 into C, then M will be linear combinations of these matrices. So we'll put all the values of the matrices. We compare both the sides and get we name these equations as 1, 2, 3, 4. Putting the equation 1 in 2, we get C2 is equal to 3. When we have C2 value, we can put C2 in 3 and 4 equation. Then we can get C1 plus 4C3 is equal to 7 minus 9 minus 2. Then the second equation C1 plus 5C3 will be minus 3. So from these two equations we can get C3 is equal to minus 1. When we have C2 and C3 value, we can directly put into the equation number 1 to get the value of C1. So 4 minus C2 minus C3, which gives us as C1 is equal. That means C1 is equal to 2, C2 is equal to 3 and C3 is equal to minus 1. So M we can write down as 2 into A plus 3 into B minus C. Here I have given some more problems for your practice purpose. So please solve these problems and you will easily understand and able to solve all the kinds of linear combination and spanning set problems from linear algebra. So I thank you for your attention.